Okay, so 5.3, number 5 here, talking about quadratic equations, radical equations, I should say, radicals, because there's a root sign there with a variable underneath. It says, identify whether either of the values k equals negative 8 or k equals negative 2 is extraneous. So remember extraneous, if you don't remember what that is, maybe write that down in your cue sheets or whatever, study that up. Extraneous means it's extra, okay? And if you think about the suffix, aneous or erroneous, have you ever heard the word erroneous? That is in error. It's a descriptor of something that's in error. So this is a descriptor of something that's extra or outside of what we are looking for. Extra, extraneous. So are any of these roots no good? So let's see. Negative 8 plus 4 equals, and you just simply substitute them in, okay? And you see what you see. So this is negative 4 equals the square root of 16. Now, if you see this in an equation, remember what we said, if the value of a radical in a radical equation is set to equal a negative number, that means that we do not have a solution that is not acceptable. So that means that negative 8 would be extraneous. And let's check out negative 2. So negative 2 plus 4 equals root negative 2 times negative 2. Well, this is positive 2 equals square root of positive 4. So because this is a positive number equaling a root on the other side, then this one's okay. This one's good. So x equals negative 8 is extraneous. Means that it's not an acceptable root. Okay? Now, we wouldn't get that necessarily from identifying restrictions on the variable, too. That's another important thing. So negative 2k has to be greater than or equal to 0. Therefore, k has to be less than or equal to 0. All right? Why? Because a negative times a negative would give you a positive, so it must be negative. And when you divide by a negative number in an inequality, you flip the sign. So that's something you have to remember. So k is less than 0. Well, both of these are less than 0. Okay? So by just looking at this, you might think, oh, both those are okay. But you do have to check because you can still have an extraneous root in this situation. Okay? So if we graph this, and let's go back to our notes here. To solve this as well, what we could do is graph. Maybe you guys remember this from previous lessons, but if you graphed y equals k plus 4, and then y equals the square root of negative 2k, and graphed both of those and found the intersection point or points, that's also the solution. We talked about that before, intersection points, graphing. Have we done that in this class or no? Very strange. You guys are looking at me like I'm really strange. We haven't done this before. This could be a pre-calculus 30 thing. All I do is math all day, so I teach all different grades, all different things. So you guys that haven't seen this? All right, I will be teaching you this like full out in a lesson, probably pre-cal 30 then. But another way to check an equation is to graph the left side of the equation as a function, and then graph the right side of the equation as a separate function, and where they intersect is the place where k is the same for both sides. It makes both sides equal. So that's another way we could actually take a look at that. And here it is, y equals k plus 4 would be the red one, it's just a straight line, and y equals the square root of negative 2k only exists when k is less than 0. And this intersection point, or the value for k that satisfies both equations at the same time, would be k equals negative 2 right here. So this x value would be the input value that makes both graphs equal the same thing. Or k plus 4 would equal root negative 2k at k equals negative 2. That's what this tells us. So there is no intercept over here as well. There's nothing, or I should say, what was the other possible solution we had? K equals negative 8. So negative 8 is over here, and you see that they do not intersect at all, you see? So over here and down here, they do not intersect, but they do intersect right there. So that's another lesson. That's later in math. I'll show you that, but that's another way you can check that. So this is no good. It's extraneous. Does that help? Awesome. Okay, any other questions from 5.3? Okay, it's asked about number 16 as well. I won't do the whole thing for you because I do want you to follow through, but I'll get you started on it, okay? And I'm not sure where things got into trouble here for you, but I'll make sure you got started on the right foot. So this question says 2 more than the square root of a number n is equal to the number. Okay, so this first sentence right here is giving us enough information to write an equation, okay? And in math, when you're given a word problem, you want to try and write some kind of equation to solve. So that's the goal. So we want to convert, this sentence into some kind of equation. And it says, model the situation using a radical equation and determine the values of n. So we're going to set up an equation and we're going to solve for the variable. So we are dealing with the number n, okay? And what it says is that 2 more than, so 2 more than is going to be plus 2 more than, the square root of the number. Well, the square root of the number is simply root n. So 2 more than the square root of a number, so that's root n plus 2, is what? Is equal to the number. What was the number? N. So here is our radical equation. 2 more than the square root of a number is equal to the number itself. Okay, so you could probably run through some options in your head, like, let's say 16 is the number. Okay, if 16 is n, root 16 is 4. 4 plus 2 is 6. That doesn't equal 16, so n is not 16. But you can kind of see that if you take a number, the square root of it's going to be less than the number, and then you add 2, you could get back to the original number. So we would have to do some trial and error, or we would solve this equation. So if on the test you just did trial and error, which I saw some of you, I think some of you on the quiz even, was like, did a whole bunch of like, I'm just going to guess numbers and work it out, like a whole bunch of times. Oh, I found one that works. Okay, that's not going to get you full marks at all, because that's not what we're going for here. We're trying to figure out how to do this efficiently using high-level math concepts, okay? So trial and error is not going to be a valid way to do these questions on your test, okay? So we want to learn the math here and try and work with the equation. So how do we solve this? What we do is we try and get n all by itself and isolate it. So I'm going to, this is a radical, and I've got n underneath the radical, so I want to get the radical all by itself on one side, which equals, root n is n minus 2. Now I square both sides, square, and I have n equals, I'm going to expand this out, that's going to be n squared minus 4n plus 4. And I'm going to let one side equal 0 and have everything over on the other side itself. So I'm going to subtract n, so it's minus 5n plus 4. Now to solve this, you have a number of different options. You could solve it graphically. You could solve it using quadratic formula. You could solve it using zero product principle. Okay? So can we factor this pretty easily? I think so. So minus 4 and minus 1 will give us positive 4, and that adds up to negative 5. So that's going to be n equals positive 4 and n equals positive 1. So we want to check to see if any of those work. So let's see our check over here. Root 4 plus 2 is just 4, right? N? Oh boy. It's 4. So that's 2 plus 2 equals 4. It seems to work. What about root 1 plus 2 equals 1? 1 plus 2 equals 1. That doesn't seem to work. So I don't think 1's going to work for us. 1's not going to work for us, but it looks like 4 will. Okay, so not 1. N is equal to 4. Everybody okay with that? I guess I did do the whole question for you. I was just going to get started, but I got rolling. I'm just so excited about math. I just can't stop sometimes. So excited. Make sense? Always check at the end. Always check. Do the math. Whatever it gives you, just check to make sure that they're both still real. Because when we go ahead and square things and, like that gets a little bit murky there. It has to fit the question still. There's some restrictions in the question that the math doesn't know about, right? If this math doesn't know about what our situation is in the question. So it's going to give you all the numbers that should work for what we're telling it to do. But then we have to check back with the question to make sure it's allowed.